So good morning students. So today we are going to study the properties of alpha, beta and gamma radiations. So understand one thing, that is alpha are particles, beta are also particles, and gamma are rays. They are electromagnetic waves or EM waves. Now just to summarize one thing, I would like to tell you that is alpha particle is nothing but helium nucleus, and the most interesting fact about beta particle is beta particles are emitted from the nucleus. They are emitted from nucleus. When are they emitted? When a neutron, that is who is having a mass of 1 AMU and charge of 0, gets converted into a proton having a mass 1 same but charge of +1. Now in order that the charge is balanced, the nucleus should emit a particle, that is a negatively charged beta particle. So this is where the beta particle originate from the nucleus. So with this we will start with our discussion of the properties of alpha particle, properties of beta particle and properties of gamma rays. Okay, so first let us discuss the properties of alpha particle. As we know, that is supposingly if I have to draw a helium nucleus, then helium nucleus will contain 2 proton and 2 neutron, and it will also contain 2 electron in its first shell. Now supposingly, if these 2 electrons, if 2 electrons are not there, we ionize this gas, that is we take out these 2 electrons, then what will remain? We will be remain with only helium nucleus. So this helium nucleus is nothing but alpha particle. Helium nucleus is nothing but alpha particle. So okay, now what is the mass of supposingly if we have to helium nucleus, what is the mass of alpha particle if we have to say? Then mass is, this is 2 proton 2 neutron, both are having 1 AMU ka mass. So the mass of alpha particle is nothing but 4 AMU. And if we know AMU is having 1.66 into 10 to the power minus 27 kg. Now okay, do we need to remember it? No, not at all. You don't need to remember it. But supposingly I will tell you how I had remembered it. See, now my phone had a numeric lock, so I had kept the num lock as 16627. So with this code, and I had used it for some days. See, now my phone is not having this lock, it is some other lock, but this was the key lock which I had used, and in that way I had remembered this particular figure of 1 AMU. So okay, let's come over to alpha particle again. See, the mass is 4 AMU, and what is the charge? The charge on alpha particle is nothing but the charge of 2 electrons. Now 2 electron, but it is having a positive charge. 2 electron, but it is having a positive charge. We know that the charge on electron is 1.6 into 10 to the power minus 19 coulomb. Now if we multiply this by 2 and have a positive sign, this would be the charge on alpha particle. Okay. Now let us discuss one more important, the most important thing about alpha particle is the ionizing nature of alpha particle. Ionizing nature of alpha particle. That is supposingly supposingly if you have a gas, if you have certain gas present over here, the gas molecules are here with the electrons intact. Now supposingly if you fire alpha particle, now alpha particle are fired along across this gas, then what will happen? The alpha particles will knock off, electrons from gas. And once they knock off the electron from the gas, then we get ionized gas, and therefore ionized gas is obtained. Among all the three, alpha, beta and gamma, alpha is having the highest ionizing power. It has the ability, since it has a mass of 4 AMU, it is having a higher mass, and it also has a speed, that is a velocity of around 10 to the power 7 meters per second, which is very less than as compared to the speed of light. But because of this high speed and sufficient mass, it has been able to knock off electron, and it has been able to ionize the gas through which it passed through. Now there is a downside to it also, that is since it interacts, since, okay, I will write over here, okay, or I will write it with a different pen, that is, since it interacts with matter through which it is passing through, it dissipates, that is, it spends a lot of energy, So normally what happens is, alpha particles can move up to a distance of only 5 centimeter in open air, up to 5 centimeter. Their travel is up to 5 centimeter in air. 5 centimeter they can travel in air, and they cannot penetrate a thin sheet of cardboard or a thick sheet of paper. They cannot penetrate. So the penetrating power of alpha particle is also very less. Now the other important point. What is the other important point? I will write it over here. That is, alpha particle, they are positively charged. So whenever they are being subjected to electric field, they are deflected towards the negative plate. So if this is the negative plate, as we have seen yesterday, that is in our last lecture, that is if this is the negative plate, then what will happen? The alpha particles will move towards, since it is having positive charge, they will move towards the negative. This is the trajectory of motion of alpha particle towards the negative plate, and they are deflected by magnetic field as well. So I can say that alpha particles are deflected by electric and magnetic field. This was one more point. Now coming on to the next point, that is they produce, alpha particles produce fluorescence on screen. Normally this screen is a fluorescent screen, that is most of the time it is made up of zinc sulfide screen, ZNS screen. Zinc sulfide ka screen, they produce fluorescence on zinc sulfide screen. Also they produce or you can say they affect, moreover we can say they affect photographic plate. That is, they may produce some spots on the photographic plate where they strike. The most important thing of alpha particle is one thing that is called as transmutation. So what is transmutation? Supposingly if we have a nitrogen atom and if we incident alpha particle in it, then it may transform into oxygen atom. Now how it happens, let us see. So if we have a nitrogen atom is having a mass of 14 and atomic number of 7. Now if alpha particle, that is alpha, you can say mass of 4 and charge of 2 is incident on it, then we might get oxygen, the mass of which would be 16 over here, or not 16, we will get an isotope of oxygen which is 17, and here we will get 8, and plus we will get a hydrogen atom also along with it, hydrogen atom also along with it. So this is called as transmutation, that is the conversion of one atom into another, that is called as transmutation. The other thing is the alpha particles are scattered by gold foil. So those who are not knowing, I will just tell you that is Rutherford had confirmed the presence of nucleus and the electrons moving around it by doing a gold foil experiment, and this was because of scattering of the alpha particle. So okay, this was there. Now let us go and study what are beta particles. Okay, so I think this you have followed. Now we will study about the beta particles. So beta particles, you are knowing that as beta particle is they are being produced inside the nucleus. Properties of, I will write beta particle. So the first thing, that is, okay, how to write beta particle? Beta particle is written as beta, you can write -1 over here, that is charge of -1, and a mass of 0. That means it is self-evident that is beta particle is nothing but an electron. An electron emitted from nucleus. When does this electron emit? When a neutron is being converted into a proton. So at that time beta particle is emitted. Now this is a representation of beta particle. What is the mass of beta particle? What is the rest mass of beta particle? The rest mass is same as the mass of electron. Mass of beta particle. And how to remember this? See, that is I have only remembered this number 1840. So 1 upon 1840 mass of proton is nothing but the mass of electron, and that would be 1 upon 1840 approximately AMU. So this is the mass of beta particle. Okay, thirdly, about what is the charge on beta particle? Beta particle is having a charge of 1 electron. 1 electron means that is -1 electron. That is 1.6 negative into 10 to the power -19 coulomb. Okay, so talking of the velocity of beta particle. So velocity of beta particle is almost to the power of 10 to the power 8. That is very close to the speed of light, very close to the 1/3 of the speed of light. But different particles which are emitted from the nucleus, they would be having different speeds. So it goes that it is having this much of you can say velocity. Fine. So the other thing, that is, okay, now you will ask, sir, actually we had studied cathode rays. Cathode rays were also rays of electrons, and now these beta particles or beta radiation, these rays are also electron which are moving fastly. Yeah, so see, these cathode rays are emitted, they are the electrons which are being dislodged from the orbital of an atom. Now the beta particles, whereas, okay, I will draw it over here only. So these are nothing but the cathode rays. This is the origin of the cathode rays, and whereas the beta particle ka rays, their origin is from the nucleus. Okay, so that is there. And chalo, now talking of the ionizing power. So ionizing power, so we can say that it is having moderate ionizing power. You can say the ionizing power of beta is around 100, 1 upon 100th time that of alpha particle, or okay, only this figure you can remember. This is sufficient for you. Okay, now let us go over to, are they being deflected by electric and magnetic field? Yes, we have seen in the last class, that is beta particles are deflected by electric and magnetic field, electric and both magnetic field. Okay, let me draw the diagram again. So if this is the radioactive substance, and if this is the, I can say this is the negative plate where, and this is the positive plate, then what will happen? Okay, I will draw alpha particles with red as what I have drawn earlier. So alpha particle would be deflected towards the negative one, and beta particles would be deflected towards the positive plate. Now since beta is having very less charge, the deflection of beta, this is beta and this is alpha. So remember one thing, that is the deflection of beta is more, we can say the deflection, that is the turning of beta, is more than the deflection of alpha particle in electric or magnetic field, Okay, now as we have seen earlier, that is even these beta particle, they produce fluorescence. Fluorescence means what? Supposing if we have a zinc sulfide screen and the beta particle goes and hits on the zinc sulfide screen, then the zinc sulfide screen, ZNS screen, will start glowing. That glow is called as fluorescence. That glow is called as fluorescence on ZNS screen. Okay, 8. They affect photographic plate. Okay, now the 9th one, and the interesting one, that is supposingly if we have a heavy a substance, a heavier substance such as tungsten, that is, and tungsten, if we incident beta particles on tungsten, all these are beta particles. These beta particles on tungsten, they are being incident on it. Then what will happen? We will be getting X-rays. So what are these? X-rays. What are these? Beta particles. So what can I say? When fast moving beta particles are stopped by heavy metal such as tungsten, then electromagnetic waves, X-rays are emitted. Okay, now lastly is beta particle can penetrate through the skin. It is not having that much damaging effect as what gamma particles have, gamma rays have, but they are also dangerous. Okay, now coming over to the last thing, that is properties of gamma rays. Okay, so what are gamma rays? Gamma rays are nothing but electromagnetic waves. Gamma rays are electromagnetic waves, and when we would be doing the chapter on electromagnetism or electromagnetic waves, we will be studying that the frequency of gamma radiation is the highest, and it is having the most damaging property. The properties of gamma rays. So these are called as gamma written by a Greek alphabet symbol as gamma, and these are rays. These are rays. Okay, now let us consider, okay, why these rays are emitted. Now whenever there is an unstable, suppose this element is having unstable nucleus A and A and Z. Now this unstable nucleus, it has been transformed onto a substance Y by emitting one helium nucleus, that is one alpha particle. So what will happen? The mass will reduce by 4 and the number of protons will reduce by 2. So this would be, sorry, Z minus 2. So this will happen. Now remember, whenever any alpha or any beta particle is emitted from the nucleus is in an excited state. So this nucleus is in excited state. How you are excited state when you see the sight of a pizza or a pasta or something? So the nucleus is also excited when it had emitted any particle. So now this excited state, I can write down excited state as only indicated by asterisk. So what will happen? It will come to the ground state. So neither nucleus nor us, we can remain in the excited state forever. So when they come to the ground state, they will emit gamma radiation. We would be discussing this in the next class also, but for you to remember, that is gamma radiation is emitted when an excited nucleus comes to the ground state to become stable. So that is there. And gamma rays, okay, it does not have any mass. They are purely electromagnetic waves. They are purely electromagnetic waves of very high frequency. So okay, very high frequency, so wavelength is very less. So what is the wavelength of these rays? The wavelength of these rays is to the order of 10 to the power minus 3 angstrom. 10 to the power minus 3. So what is the velocity of these rays? Velocity is the velocity of speed of light, that is 3 into 10 to the power 8 meter per second. Okay, okay, what about their penetrating power? Since they have a lot of energy, so their penetrating power is the most. So you can say a 50 centimeter, they can penetrate a 50 centimeter of an iron block easily. So what do we use? They have a lot of energy, so they can penetrate iron block or something very easy. So we okay, so what is being used to stop them? Either lead PB or thick concrete is used to stop gamma rays. Okay, now this is the penetrating power. Ionizing power is the least. ये ionize नहीं कर सकते, they cannot ionize gas, but their penetrating power is very high. Okay, so these are there. And what else do we need to? So same thing is there, that is gamma rays produce fluorescence. On zinc sulfide screen, and they are not deflected by magnetic field, by electric or magnetic field. Okay, this is there. And gamma rays are also emitted from the nucleus. And okay, and now earlier we had studied about the X-rays. Now let us see what is the difference between X-rays and gamma rays. So see, X-rays, when are X-rays being produced? See, whenever an electron from a higher level comes down to a lower level, to a lower level, jumps from a higher energy level to a lower energy level, what happens? It emits X-rays. It emits X-rays. And we have seen that whenever beta particles are being fired onto heavy metals such as tungsten, the tungsten will emit X-rays. So this is how the tungsten is emitted. So the source of X-rays is when de-excitation of electron from a higher energy level to a lower energy level. Okay, now what about gamma rays? Gamma rays are being produced in nucleus. When a nucleus from a higher excited state comes to a lower excited state, or you can say to a ground state configuration. Okay, so the most important or the damaging part of it is that is they are extremely dangerous for humans. They can damage the tissue and they can damage a whole lot of things. So but actually we are utilizing this damaging effect of gamma radiation in order for the prevention of cancer. So I hope you have understood this thoroughly. So keep studying. All the best. I will also upload the notes for this particular section, and I will see you in the next class for discussing more about the properties of alpha, beta and gamma, and which are required for the examination. You would be getting direct questions from that particular topic. Okay, so bye bye, keep studying.